Alright, this is going to be scuffed as hell. Don't worry about it. Also, if you're wondering what all these marks are, it's because I'm writing on the back of the quiz. Just don't sweat it. I'm saving paper, okay? Anyway, we got the matrices A, the 3x3 matrix A. It's not going to go well. Matrix A, 3x3, it's got these values. Then we got B and C. Our equation, or I suppose technically it's not an equation because there's no equal sign, but listen, let's not get hung up on the terminology, because I'm not getting it. The determinant of the inverse of A times the determinant of B times C times logarithm base 3 of 1 over 243, all divided by the trace of the inverse of A. What the hell does that mean? Well, let's start breaking down what the hell is the inverse of A. Quite simply, it's the equivalent of taking this, like if A were just like a normal number, it'd be kind of like just taking it and having it divide 1. So you can think of A inverse almost like 1 over A. But of course you can't exactly do that with matrices because, you know, does this look like a normal number to you? So you gotta do some funky stuff. So the way we're gonna find it is by taking A. So gotta write all this out again. 1 over 5, 0, negative 1, 10, negative 4 over 35, negative 2 over 7, 19, 76, 35 over 7, negative 11 over 70. And then I think this is called, yeah, this is called an augmented matrix. And then here I'm going to put what's called the identity matrix, which essentially is the matrix version of 1. Now, what the hell was all this for? I'm going to take this and I'm going to do what are called row operations to turn this side into what's here. And whatever I do on this side, I'm going to do on here. And by the end of it, once this equals 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, this is going to be our A inverse. And the reason this works, well, actually, let's do it first, and then I'll explain to you why it works. So, first thing I'm going to do, I'm going to take each of these rows and like get rid of all these factors. So I'm going to take row 1, I'm going to times it all by 35. So we're going to get 7, because 35 over 5 is 7. Then negative 4, 6. And then the adjective part, remember, I'm also, whatever I do on this side, I'm also doing to this side. So this turns into 35, then 0, 0, because, you know, 5 times 0 is still 0. This row, I'm going to times by 7. So it's still going to be 0. It's going to be negative 2, 3, 0, 7, 0. Then this, going to times it all by 70. So we get negative 7, 19, negative 11, 0, 0, 70. Right. Yeah, no, 70. Sorry, got mind flood. Okay. So now, we know that this row is going to have to be 0, 0, 70 eventually, or 0, 0, 1 eventually. So let's get rid of the 7. Now we can't just add 7. Okay, so like the different row operations we can do is we can multiply a whole row by some sort of constant, or we can add rows together. So here what I'm going to do is I'm going to take row 3 and then I'm going to add row 1 to it. So that's going to be, so row 1 I'm not touching. That all stays the same. Same with row 2, not touching it. And then, so row 3, going to add row 1 to it. So 7 plus negative 7 is 0. Negative 4 plus 19 15. 6 times, or 6 plus negative 11 is negative 5. And in here, do the same thing. So 35 plus 0, 35, both zeros, then 70. Okay, next up, okay. So see here, we got negative 2, 3, negative 4, 6. And we know we want those to be zeros. So what I can do is I can just add 2 times row 2 to row 1. Oh, sorry. I can subtract 2 times row 2 from 1. Yeah. And while I'm doing that, I'm also just going to divide all this by negative 5, because I know I want this to be 1 eventually, so I'm just going to take care of that. So let's do that. So essentially what I'm doing is negative 2 times the second row, and then adding that to row 1. So 0, not going to change. Here, negative 2 times negative 2, it's going to be 4. 4 plus negative 4, 0. 3 times negative 2 is negative 6, plus 6, 0. And again, doing the same thing on this side. So this is going to be, I haven't messed up by the way, right? Yeah, we should be fine. Okay. So this is still 35. It's going to be negative 14, and this is still 0. We haven't touched row 2. And then here, I want to divide it by negative 5. So 0, negative 3, 1. Cool. So this becomes negative 7, 0, negative 14. Yeah, that's right. Okay, cool. So now, I want to divide this by 7, just get 1, which is what we want up here. As for these guys, that's a tricky one. I think what I'll do is I will subtract 3 times the third row from this row to get this to be 0. And yeah, let's go with that. So we're just kind of going. So this is going to be divided by 7. So 1, 0, 0, 5, negative 2, 0. We were, getting rid of this 3, so negative 3 times this row plus that. So it's going to be 0. Negative 3 times negative 3 is 9, and plus that it's going to be 7. And this should be 0. So negative 3 plus that is going to be 21. That stays at 7. Negative 3 times that is going to be 42. Yep. And then this stays the same. So now I'm going to divide this middle row by 7. Just do that real quick. 6. Right? Yeah. And then just multiply this by 3, add it to the bottom row. So we should get negative 2, 0, 6, 1. So 3, multiply by 3, add it to here. So 3 times 3, 9, plus negative 7, it's going to be 2. It's going to be 3. It's going to be 18 minus 14, so 4. Alright, so this should be a inverse. Let me check with my cheat sheet. 5, negative 2, 0, 3, 1, 6, 2, 3, 4. Hell yeah. Alright. So how the hell does that work? So I stated before, A inverse is kind of like 1 over A, but not exactly because, they're matrices. But going along with that example, you can think of this kind of like A equals 1. Maybe not equals, but just like, they're in the same equation, right? And right now, I turned A into 1. So it's kind of like I divided both sides by A, and this of course becomes 1 equals, and then 1 over A, we already stated, that's kind of like A inverse. So this becomes A inverse. So you kind of see how that works? A set it to 1, A set to 1-ish, sort of. Then do all this quote-unquote division. Then you get 1, and then A inverse. Aha. I feel like I might have said negative A a couple times. If so, that's just because I'm stupid. It's not negative A. Okay, so now we have A inverse. Poggers. Oh boy. Okay, so now let's take care of trace first because it's easy. So what the hell is trace? The trace of a matrix is real simple. You just add the stuff along the diagonal. So top left to bottom right, all the numbers in there, you just add them up. So in this case, trace of A negative 1 is just 5 plus 1 plus 4, which is just 10. Easy peasy. Cool. Now, determinant. That's what that means, determinant. What the hell is that? So that gets a little complicated. Actually, you know what? It gets so complicated, I'm gonna save it for later. As I said, do B times C first. So we're multiplying. Sorry, the legs of the tripod are getting in the way, so it's gonna be a little funky. Okay. So how the hell do you multiply matrices together? How the hell do you multiply matrices together? Hold on, I kind of forgot. Hold on. Multiplying these two together. Let's write it out first. So 8, 3, 3, 4. 5, 1/3, 9, 8. Now, I'm afraid it's not as simple as just like multiplying the like things. So, like, you can't just do 8 times 5, 3 times 1/3, blah, blah, blah. I'm afraid that's not how it works. That is how it works for addition and subtraction. You can't just do that. So, like, if we were adding these two together, it'd just be 8 plus 5. So, first thing would be 13. 3 plus 1/3. So, second thing would be 3 and 1/3, etc., etc. But for multiplication, if I remember correctly, you do some weird shit. So the one on the left, I think what you do is you start with the first row. Then on the one on the right, you start with the first column. And I think what you do is you multiply the first thing in the row with the first thing in the column. And then you multiply the second thing in the row with the second thing in the column, and then you add them together. What? Yeah, no, it's kind of weird, but I'm pretty sure that's how that works. So what we're going to end up with is 8 times 5 plus 3 times 9. I should have actually checked with this before I started the recording, but it's too late now. I'm too invested. We're 14 minutes in? I'm not sure I'm going to have enough space in my phone for all this. Oh no. Anyway, because that was the first row, that was the first column, that goes in the first row, first column slot. So now we move on to the second row, stay with the first column to get the first row, second column slot. So 8 times 1/3 plus 8 times 3 and then we move on to the second column. Second row. So 3 times 5 plus 4 times 9. And for the last thing, 3 times 1/3, which is just 1, plus, I'm not sure why I'm just, write it out, right? 3, plus 4 times 8. All right, so if you wanted, you could like simplify this down, but I think that could be a pain, so I'm just gonna leave it for now. And now let's move on. Determinant. What the hell is that? How do you find it? I'm going to leave the explanation for what it is for possibly never. Maybe you can Google it if you want. I don't know. We'll see if we have time. For now, finding it with a 2x2 matrix like this is easy enough. All it is if we label these A, B, C, D, the determinant of a 2x2 matrix is just A times D minus B times C. Now, again, like, I could go into why this is, but I'm realizing now, I'm not sure I can actually explain why, it just kind of is. But anyways, let's do it. So, do I need to simplify this? It's probably easier if I simplify it. Yeah, okay, we can do that real quick. Yeah, okay. So this is going to be 40 plus 27, 67. See, this is why I didn't want to do it, because, like, what the hell is this, man? I didn't do this right? Yeah, we'll see. Yeah, because there's 3's in this. Yeah, it should be fine. So anyways, this is going to be... eight times 3. It's 24. Put it all over 3. It's 24 times 3. It's going to be 72. So it's going to be 80 over 3. Yeah, that seems about right. It's going to be 15 plus 36. So 51. 15 plus 36. It was 35. Yeah. And it's just going to be 33. Yeah, cool. So let's find this. So it's going to be 67 times 33 minus 80 over 3 times 51. So I'm pretty sure you can split up 51 to be 3 and 17? Yeah, because 3 times 7, 21. Okay. Then we just have this cancel out with this. So 17 times 80, which is what the hell? Okay. Calculator time. Alright, so we're doing, what was it again? 67 times 33 minus 80 times 17. And I'm pretty sure this calculator does PUMDAS, so let's not sweat it. Anyways, that's going to be 851. You guys see that? It's not a frame. How do I? Yeah. 37 times 3 is that. 851. Yeah. We go with that? Cool. So anyways, this is det BC. Cool. So far, we have the trace. We have this. We'll get to it. And let's just do this right now, because I'm realizing now, why the hell did I force myself to find the determinant of a 3x3 matrix? Because there is no easy thing like this for this one. No, it's going to be kind of a pain. But hey, we'll get to it. Let's first find this first, because it's easy. So we got, let's do it here. We got log base 3 of 1 to 43. Now first off, what the hell is log? So what log is it's a way to undo exponents you can think of. So kind of like, you know, how multiplication is kind of like the opposite of like division. Logarithms are kind of like the opposite of exponents, but might be right. But you might be like, what about square roots? They are also the opposite of exponents, sort of. It's, okay, so exponents, right? You got like 2 to the 3 equals 8 or whatever, right? It's bad looking too. Okay. If you have 8, you can find what 2 by taking the cube root of 8, right? So this cube root kind of undoes the cubing of this. But what if you know 8 is something to the 2, right? And you want to find out what this is. That's where logarithms come in. So you take whatever your base is, and you're like, okay, log, in this case, it's going to be base 2. Then you put 8 in there, and that is going to get you 3. So what am I saying here? I'm saying that something to the third equals 1 over 2, 4, 3. Now, I'm going to make things a little easier on myself and just tell you that 2, 4, 3 equals, man, these notes are a mess. It's 3 to the 5th. How do I know that? It's because that's how I got the number. I just like, hey, what's 3 to the 5th? Oh, it's that, okay. So in other words, we can rewrite this as log base 3 is 1 over 3 to the 5th. Now here's the deal. When you have 1 over something, you can just treat that as multiplying its exponents by negative 1. In other words, what I'm saying is that this equals log base 3, 3 to the negative 5. And this is true for all things. You can take like 1 over, 69 to 69. That's just equals 69 to the negative 69. This is just true. So anyways, we got this, right? Now remember, the whole deal was that, hey, base number, right? We're trying to figure out what this x is. Well, guess what? The base numbers frickin' match. So log base 3 of 3 to the negative 5 is just going to be negative 5. These effectively cancel out, and that's how you get negative 5. And that's why I was so annoyed with you calling ln e to the squared complex math. Because listen, ln, that's a key. I always write them as an h for some reason. I just combine the l and the n. ln is just log base e. Literally, that's exactly what it means. ln is log base 3. So it's just like, it's the base. And with the base, it's just 2. It's just 2. And I'm just like, ah. Anyways. So this right here. This is just negative 5. Alright? So anyways, equals negative 5. Neato. I got 4 minutes left of video? Ah! Alright. I'm just gonna spill the beans, because my phone does not have enough space for me to go through the full thing of this. But I'm just telling you, this is going to be negative 70. And honestly, like, there's really no reason we should do this out by hand. I might make a follow-up video. But anyways, like, honestly, like, if you had to find the determinant of 3x3 matrix, not this one actually, A inverse, just find an online calculator. Trust me, you don't want to do it. Anyways, with this, we have all the values we need now. Determinant of BC, that was 851. Logarithm of this, it was just negative 5. This boy, trace, was 10. 10. So for all this, toss in the calculator, what do we get? We have negative 70. Alright, it's not going to be in frame. That will show you after. Negative 70 times 851 times negative 5 divided by 10 equals 2, 9, 7, 8, 5. Yeah? 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 Alright. Buggers. We did it. We did the math. Hey, Roy. Where's the calculus? Where's the trigonometry? You can get more advanced than this. Trust me, matrices are cool and all, but like, there's other advanced math. I don't wanna. Screw you. Alright. I'm gonna make a follow-up video once I get this video off my phone, because it's taking up like what little space I have left. So if you really want to figure it out, that'll do it for you. That, or you can just Google it yourself. Whatever. I'm done. Peace. Peace.
Hey, I forgot my bit. I was gonna do a bit at the end of the video. What? All right.